yesterday we stopped at I guess contact force between two blocks. And I was asking you, do you have any doubt in this question? Remember we did this question jahan par we took three blocks. One was of 3 kg, 2 kg, and the last one was of 1 kg. And then we calculated the net acceleration as well as the contact force between them. So this was a 3-block system, and I gave you the formula for 2-block system. So I hope you were clear with the solution yesterday itself. But if you have any doubts, you can tell me now also. Prasanna, especially Prasanna and Deepika. Okay. I think Marini has not joined. Yeah. Both of you can tell me if you have any doubt in the last question of yesterday, and then we can move forward quickly. Just have a look. You can have a look first. Just have a look and tell me. This was a 3-block system. That will do. I'll just quickly have a look if any more good cases are left or not. But I think that was all. Connected motion bodies में ज़्यादा कुछ नहीं आएगा. आपसे net acceleration पूछेंगे, mass देंगे, आपको external force देंगे. And what is the basic concept of the shortcut is to calculate contact force, that you have to take the force in the contact force formula, that force which is not acting directly on the masses. Okay. Agar if I'm talking about the 2 kg block, so both the blocks are not acting directly on 2 kg. But if I talk about 1 kg block, you can see that the 6 Newton force is acting directly, and on the 3 kg block, the 12 Newton force is acting. So what is the logic here is that you don't have to take the force which is acting directly. No, sir. No, sir. Okay, both of you are not clear. Okay, we can do this again. Dekho. I know that both of you know how to calculate acceleration. So acceleration is nothing but net force upon net mass. So net force is 6 because the forces were in opposite directions, 12 Newton and 6 Newton. They both act in opposite directions. That is why the net acceleration is 1 meter per second square. Moving on to the contact force C1. What is contact force C1? C1 is the contact force between 3 kg block and 2 kg block. ध्यान से देखो डायग्राम को. 3 kg और 2 kg block के बीच की contact force है C1. Now, sorry. What was the formula which I told you for a 2-block system? For a 2-block system, what was the formula? If the force is acting from both the sides, that first you have to calculate the contact force between M1 and M2. So first you will see the contact force with reference to M1 block. So when you will see with reference to M1 block, then you will write M1 into F2. Now why M1 into F2? Because F2 force is not acting directly on M1. Okay, F2 force is acting directly on M2. But if I want to calculate contact force between M1 and M2, and that too with reference to the M1 block, so I must not include the force which is acting directly. And which is that force? It is F1, which is acting directly on M1. तो जो force directly act कर रही हो block पे contact force निकालने के लिए उसको include ना करें. तो मुझे M1 के रेफरेंस से कॉन्टैक्ट फोर्स निकालना है, तो जाहिर सी बात है कि मैं M1 को इंक्लूड नहीं करूंगा. ठीक है, I will not include F1 को इंक्लूड नहीं करूंगा. I will not include F1. That is why the formula when I calculate with reference to the M1 block is M1 into F2 and then the total mass. Similarly, now I want to calculate if I want to calculate contact force between M1 and M2, obviously it will have to be with respect to both the blocks. ठीक है, M1 के respect में भी देखेंगे, M2 के respect में भी देखेंगे. So we have to see this diagram with respect to both the blocks. So with respect to M1, the contact force is this with respect to M1. Now with respect to M2, what will be with respect to M2? It will be M2 into F1. M2 into F1 because F1 is not acting directly on M2. Okay. And force which are acting directly on the block does not contribute in the contact force. I told you that yesterday. Okay. So that is why the formula is M2 F1 upon M1 plus M2. Now just see, imagine this thing in the 3-block system. 3-block system में क्या हुआ? I want to calculate C1. C1 forces between block 3 kg and 2 kg. So between 3 kg and 2 kg, I told you 3 kg block, 3 kg block is M1, 2 kg is M2, and 1 kg is M3. I want to calculate between M1 and M2. Now I have to take a reference of all the 3 blocks in this case, because it is about the force. Let me make it more clear by drawing the diagram again. You see this thing. Three kg, 2 kg, and 1 kg. These 3 blocks are there. And I'm saying I have to calculate the contact force between these 2 blocks. And there was an external force F1 and there was an external force F2. Okay. What does the contact force do? Contact force is responsible for moving of all the blocks together. Okay. Contact force is responsible for moving or giving acceleration to all the blocks so that they move at the same time. Okay, and they stay together. So I can say that the contact force, basically contact force between 3 kg and 2 kg is responsible for pushing both the 2 kg block and the 1 kg block in the right direction, because the net force is in the right direction. Okay, the net acceleration is in right direction in it. It is in this direction. So I can say the contact force between 3 kg and 2 kg is responsible for pushing 2 kg and 1 kg towards right side. ये बात समझ में आ रही है आपको कि कॉन्टैक्ट फोर्स कर क्या रही है? कॉन्टैक्ट फोर्स बाकी दोनों ब्लॉक्स को पुश कर रही है. 3 kg और 2 kg के बीच में जो फोर्स है वो किसको पुश कर रही है? 2 kg के ब्लॉक को और 1 kg के ब्लॉक को. कहां? नेट फोर्स की डायरेक्शन. सो कॉन्टैक्ट फोर्स ऑलवेज पुशेस दी other blocks on which it is not acting directly towards the direction of what? Towards the direction of net force. Now, if you look at it this way, oh yeah, इसमें page is over almost. Okay, no problem. What we'll do is we'll understand here only. So since there are 2 external forces, F1 and F2, so the contact force contribution in contact force will be due to both the forces. ठीक है, 2 external force लग रही हैं and both the forces are not acting directly on this in this 3 kg and 2 kg block, in between 3 kg and 2 kg block. So contribution will be due to both the forces. So the formula will be, let's say this C1, formula for contact force between 3 kg and 2 kg, let's all call it C1, will be nothing but, first of all, I'll see due to F1. What is the contribution of F1? So how will I see the contribution of F1? F1 is pushing 2 kg and 3 kg. So I will write 2 plus 1 into F1 upon the total mass of the system. Okay, because ultimately the whole system is moving together. Ultimately, whole system is moving together. That is why M1 plus M2 plus M3. So 3 plus 2 plus 1 is nothing but 6. Now, plus I will see the contribution of F2 force. Now, F2 force is acting on 1 kg block. So it will be responsible for pushing both the 3 kg and 2 kg block. Do you get it? It will be responsible for pushing both the 3 kg and the 2 kg block. But since we know that the net acceleration is towards the right side, and the block which is farthest from this external force F2 is 3 kg block, so the maximum contribution of this F2 external force will be on the 3 kg block. So when I will calculate the net force between 3 kg and 2 kg. So the most effect of this external 6 Newton force will be on 3 kg block. Most of the effect will be on 3 kg block. So that's why you see in the formula above, I have written M1 F2 upon the total mass, because the maximum effect of this 6 Newton force will be on 3 kg block. Maximum effect in what sense? Maximum effect in the sense of contact force. I'm getting a sense that you're not getting it. Achha, let me do one thing. Let me make a start to this question all over again. मुझे ऐसा लग रहा है कि ना ठीक से आप लोगों को डिलीवर हो नहीं रहा है अभी. 3 kg, 2 kg, 1 kg. Two external forces. One is F1, 12 Newton, and the other one is F2, 6 Newton. First question was to calculate the net acceleration, which is nothing but net force upon net mass. Net acceleration क्या होगा? Net force upon net mass. That is it. Now, if they are moving in the right direction, that I forgot to mention, that all of them, all the three are moving in the right direction. This is their direction of net acceleration. So net force will be, which force is responsible for the motion in right direction? It is F1. Which force is responsible? It is F1, because F2 is acting in left direction. So if the overall motion is in right direction, it is due to F1 force. So we will write F1 minus F2 upon what? Total mass, which is 3 plus 2 plus 1. Or if I say M1, M2 and M3, then it will be in that sense M1, M2 and M3. Now, what is F1? 12 Newton. What is F2? 6 Newton upon 6. So first part is clear, I hope now. What was the second part? Calculate contact force between 3 kg block and 2 kg block, and let us call it as C1. Contact force C1. So calculate contact force C1 between 3 kg and 2 kg. Now what you need to understand is that the contact force between 3 kg and 2 kg will be due to both the forces. That is both 12 Newton and 6 Newton. Okay. जो contact force होगा 3 kg और 2 kg के बीच में, वो दोनों फोर्सेस की वजह से होगा. दोनों फोर्स कौन कौन सी? एक हमारे पास F1 है और दूसरी हमारे पास F2 है. Malini has joined. Okay. No sir, no sir. Okay, I know it's been a bit difficult for you. ठीक है, तभी भी और आराम से मैं ट्राई कर रहा हूँ एक्सप्लेन करने का आपको. जस्ट बी विद मी. ठीक है, अगर कुछ समझ में नहीं आए तो यू कैन गिव मी अ हैंड रेज वाला ऑप्शन. ठीक है, एंड आई विल इनेबल योर माइक एंड देन वी कैन डू इट. This is my code. Okay, so we have to calculate contact force C1 between 3 kg block and 2 kg block. So what you need to see, what was the shortcut? Since contact force between 3 kg and in 3 kg and 2 kg block will be contributing for the movement of both 2 kg and 1 kg block together, so I will write the formula C1 is equals to M2 plus M3, M2 plus M3, and which force is not acting directly on M2 and M3, which force is not acting directly on M2 and M3? It is F1. F1 is the only force which is not acting directly on both M2 and M3. Okay, so I am multiplying it with F1 because it is not acting directly on M2 and M3, and since the contact force between 3 kg and 2 kg is responsible for pushing both these blocks in the right direction, that is why I have to include the mass of both of them. ठीक है, जो कॉन्टैक्ट फोर्स इन दोनों के बीच में होगी 3 kg और 2 kg के बीच में, वो किसके लिए रिस्पॉन्सिबल है? वो रिस्पॉन्सिबल है 2 kg और 1 kg दोनों को towards right push करने में. So this contact force C1 is pushing both the 2 kg and the 1 kg block towards right side. That is why I have included mass of both of them, M2 and M3. And why I have multiplied with F1? Because we multiply with that force which is not acting directly on both of them. So F1 is the only external force which is not acting directly both on 2 kg and 1 kg block. So M2 plus M3 into F1 upon the net mass. Net mass of the system has to be taken. Okay. Now, we will see the contribution of this. This was the contribution of F1 force. This was the contribution of F1 force. Sorry. Yeah, contribution of F1 force. Now we will see the contribution of F2 force. Now you see F2 force of 1 kg block. F2 force of 1 kg block is acting directly on 1 kg block. It is acting directly on 1 kg block. So I cannot say that it is responsible for pushing both the 1 kg and 2 kg block on the right side, because I can clearly see that the F2 force is pushing this 1 kg block towards the left side. So I cannot say that F2 force is pushing both the 1 kg and 2 kg block towards the right side. So I will exclude the term M3. Okay, I will exclude the term M3 from this, and I will write the actual contribution of the F2 force, which is on the M1 block, 3 kg block. Actual contribution of F2 force is on 3 kg block, and it helps the 3 kg block to move towards right side. That is why in the formula now I will write plus M1 multiplied with F2 upon the total mass. Okay, understand it like this. कुछ समझ में आया? आपको दोनों फोर्सेस का कंट्रीब्यूशन देखना है. दोनों फोर्सेस का कंट्रीब्यूशन कैसे देखेंगे? हाउ विल यू सी द कंट्रीब्यूशन ऑफ बोथ द फोर्सेस? यू विल सी first of all that the forces are acting on which block. Okay, and when you are writing contact force on that block or in between that block and another block, you will not include the force which is acting directly on either of the blocks. ठीक है? Since I am writing the contact force between 3 kg and 2 kg block, I cannot write I cannot include 1 kg. Okay, that is pretty much obvious, because the F2 force is acting directly on 1 kg block. So which one of the mass was left in this formula? Which mass was left? Only M1 was left. So the contribution of M1 will be due to F2, and the total mass will be there in the formula. So this is the formula for calculating the contact force between 3 kg and 2 kg. Similarly, if you want to calculate the contact force between M2 and M3, now you want to calculate contact force between 2 kg and the 1 kg block, and let's call this as C2. What will be the formula for C2? First, I will write the formula. It will be formula between, now what is this contact force is doing between the 2 kg and the 1 kg block. This is responsible. This force is now responsible between 2 kg and 1 kg block, is responsible for pulling. Okay, this force is now responsible for pulling both the M2 and M1, both M2 and M1 towards the right side. Okay, the contact force between 2 kg and 1 kg. The contact force between 2 kg and 1 kg is now responsible for pulling both the 3 kg block and the 2 kg block towards right side. That means that the F2 force is responsible for pulling M1 and M2 towards itself. So I will simply write that this contact force between 2 kg and 1 kg is responsible for pulling M1 and M2. Sorry, काफी ज़्यादा दूर लिख दिया. Is responsible for pulling M1 and M2. M1 and M2, which was responsible? F2, towards the right side. And this thing total divided by total mass remains common. Plus, what is that force external also doing? What the contact between 2 kg and 1 kg also doing? Nothing more than that. F2 is responsible only for pulling both 3 kg and 2 kg block towards the right hand side. Now, what is F1 contributing here? What is the contribution of F1 force between 2 kg and 1 kg? The contribution of F1 force between 2 kg and 1 kg is that it is pushing this 1 kg block towards the right side. It is pushing the 1 kg block towards the right side. So I will simply write M3 into F1 upon M1 plus M2 plus M3. Okay. So that's how both the formulas are made, and now you have to just put the value and get the answer. Just tell me if you are clear about this. If you're clear about this, just give me a quick yes or no. Yes. काफी टाइम लग गया इसमें क्वेश्चन में. टेल मी इतना टाइम क्यों लगा रहे हो आप लोग? इतना टाइम तो मैंने समझाने में लगा दिया. गाइस रिप्लाई. ओके यस सर यस सर यस फाइनली. एक और क्वेश्चन देता हूँ. आई डू नॉट बिलीव यू गाइस. तुमको समझ आया नहीं आया, आई डोंट बिलीव यू. आई गिव यू अ क्वेश्चन, ट्राई टू सॉल्व इट. दे दे क्वेश्चन एक. ओके आई गिव यू इजी वन. 14 kg, 4 kg and 2 kg, and the acting force on this is 12 newton external on the 14 kg block. These are masses. Okay, you have to calculate the contact force between A and B. This is your A block, B block, C block. Contact force between A and B, this you have to calculate. I hope the question is clear. Solve it quickly. Also give me the net acceleration. Okay, this is the first part. You have to also calculate A net. Net acceleration में calculate करो. Simple. 3.9. Only one answer. What about both of you, Deepika or Prasanna? Deepika and Malini. आप दोनों का कोई आंसर नहीं आ रहा है. 3.6 Newton and 0.6 meter per second square. Okay. Let's see. Net force कितना है? Net force is your 12 Newton upon the net mass is 14 plus 6, 20. Okay, 0.6. About C1. So what formula you will apply? Simply 4 plus 2. If this is M1, this is M2, and this is M3, the formula will be M2 plus M3, because the contact force between 14 and 4 kg is responsible for pushing M2 and M3 along the right hand side. Okay, so M2 plus M3 into F1 upon the total mass. So it will be your 6 into 12 upon 20, which will be 3 and point, yeah, 3.6. 3.6 Newton. So both the answer of Malini is correct. Let me see what Prasanna gave. Prasanna said 3.9. Prasanna 3.9. 3.6 was the correct answer. I think you have a calculation mistake. Okay, so 3.6 and 0.6 are correct. Okay. Now try to solve. A similar type of question, but in this type, the forces are applied on both the sides. This is 2 kg, this is 3 kg. This is 3 kg and this is 1 kg. This is signal force F. Okay, and they are moving towards right side only. This is your net acceleration direction. So there will be some tension in the string in this side. There will be some tension in the string in this side. What you have to calculate in this case is calculate this. If I say this is T1 and this is T2, the simple question is calculate T2. This is F1 and this is F2. If F1 is equals to 14 Newton, 14 Newton, and F2 is equals to your 8 Newton. So if this is 14 Newton and this is 8 Newton, you have to give me the tension between this 3 kg block and the 2 kg block. Tension in the string between the 3 kg block and the 2 kg block. This is based on the very same formula which we did right now for the three block system. Very same formula. Okay, just I'll give you a hint that we replace the contact force with the tension, because contact force is present when the blocks are in physical contact and the tension is present when the blocks are attached via string. So the formula will remain same. Just tell me if the screen is still visible. My network fluctuated. मलिनी स्क्रीन दिख रही है, जरा बताओ. And others also. Malini, Prasanna, Deepika. Is the screen still visible? And am I audible? Okay, good. Just see your question. Okay. Calculate the tension, T2, and the net acceleration. Net acceleration is the complementary thing. You have to calculate the calculation. After this, we'll do Atwood machine. Atwood machine is very interesting. Not interesting to be said. It's just a similar type of application. बिल्कुल इसके जैसा ही होता है, पुली के फॉर्म में होता है वो. Okay, so we will do Atwood machine and then we will do some cases of the spring force. So meanwhile, I hope all of you must have noted the question. Let me see the open board. I have some notes for the spring case. Yep, this was it. Okay. Ideal pulley and rope system. No? Yeah. How much time will you take? A net 1, T2 20 by 3. Okay. Answers have started to come. Let's see. Deepika, why are you not trying, beta? At least try तो करो. Answer गलत आएगा max to max और क्या होगा? Just don't stop trying. इस डर से कि आंसर गलत आ गया तो क्या होगा? A net निकालना तो simple है. A net is what your net force. Net force will be nothing but 14 minus 8 upon में total mass, which is 3 plus 2 plus 1, 6. So the net acceleration will be 6 upon 6. That is 1 meter per second square. A net is 1. Answer was correct. Prasanna, A net will be 1. And the T2 will be 20 by 3. 20 by 3. 20 by 3. I am afraid T2 आपने सही निकाला है क्या? How will you calculate T2? Basically, you see tension in the 1 kg block. Sorry, not in the 1 kg block. Tension in the 2 kg block is the only force which is responsible for its motion towards the right side. Okay, so if I draw the FBD of the 2 kg block, I can simply write that the tension will be pulling it towards the right side, and there is an external force F2 which is trying to pull it towards the left side, and we all know that F2 is equals to 8 Newton. So if I will write the equation of motion, it will be T2 minus 8 Newton, because T2 is the bigger force. Obviously, why T2 is the bigger? Because we know that the direction, net final direction of acceleration is towards right. So despite the F2 force, which is pulling it towards the left hand side, as you can see in the diagram. So T2 is pulling it towards the left hand side, but despite the F2 force, the 2 kg block is going towards the right hand side. So this clearly states that the tension is greater than the F2 force. So T2 is greater. So we will write T2 minus 8 Newton is equals to net mass into the net acceleration A net, which we all know is 1 meter per second square. So T2 will be 8 plus 2, that is 10 Newton. How on earth can it be 20 by 3? That's not even near. 20 by 2 लिखना चाह रहे थे क्या आप? और 20 by 3 सर मिस टाइप हो गया, और 20 by 3 लिखना चाह रही थी. मैं एक बार को वही सोचा कि मलिनी शायद 20 by 2 लिखना चाह रही हो, बट फिर मैंने ध्यान से देखा तो इट वाज 20 by 3. सो या now is this solution clear? Is solution clear? भाई नहीं आया क्या अभी तक? And who has left the class? Deepika has left the class. Okay. So T2 is equals to 8 Newton. T2 is equals to 8 Newton. T2 is greater than 8 Newton because the 2 kg block is moving towards the right hand side, as you can see in the diagram. That is why when we will draw the FBD, we will draw T2, which is towards the right hand side. You can see the direction of T2. T2 is towards the right hand side. What is tension doing? Tension is responsible for pulling the 2 kg block along the right direction so that the system of both the 3 blocks moves together. That is the role of tension here. Okay, I told you previously also tension. What does tension do? Tension ensures in the string that the system moves together. The system has the same acceleration, and all the blocks move together. So tension will be pulling the 2 kg block towards the right hand side, despite that there is an opposing force on the 2 kg block F2, which is equal to 8 Newton, which is pulling it towards the left hand side. So it is opposing the tension force. It is opposing the tension force. It is opposing the direction of motion as well. but since the tension is greater, so the direction of motion will be towards right hand side only, which is the direction of the F1 force. Okay, or also we can see the direction of tension. That is why I've written tension minus 8 Newton, T2 minus F2. I should have written T2 minus F2 here, but I directly wrote 8 Newton because F2 is equals to 8 Newton, but the correct form will be T2 minus F2. T2 minus F2 will be equal to net force. Net force is mass into net acceleration. So T2 is equals to 8 plus net acceleration. So that is what it is. Okay, now we'll study motion of bodies connected by a string passing over a pulley. Connected by a string passing over a pulley. Okay, so this is sometimes also called as Atwood machine. Atwood machine. Generally, this type of arrangement is called Atwood machine. What is this arrangement? It is somewhat like this. There is a pulley, okay, and from this pulley, two masses are hanged. Okay, this mass M1 and this is the mass M2, which are hanged, okay, from this pulley. Now, this system will have some certain acceleration. Let's suppose, let me draw this again. Okay, let me draw it a bit smaller. This is the pulley. Okay, it is attached to the some solid support, and a string is passing over the pulley, and to the string the two masses are hanged. Okay, these masses are nothing but M1 and M2, and I say that the whole system is moving towards downward. Okay, the net acceleration is downwards, towards downwards. Net acceleration of the system is towards downwards. Okay, so that means M1 is moving downwards. If M1 is moving downwards and they are connected over by a single string, अगर M1 नीचे जा रहा है देखो और वो single string से connected है पूरा system, तो M2 कहाँ जाएगा? Obviously बात है M2 will move upwards because they both are connected by a single string. Okay, this string and this string is same string, so they are connected over the pulley by the same string. That is why if I say that the net acceleration of the system is downwards, that means that the M1 block is moving downwards, so M2 block will automatically move upwards. Okay, then only the system can remain together. ठीक है? So let me imagine there will be a force acting downwards on M1 block, which will be the weight of M1, M1G, and similarly on the M2 block. So weight of both the blocks will be force of gravity. Okay, will be acting downwards, which will be equal to M1G and M2G respectively. Okay, and if M1G is moving downwards, there will be a tension in the string upwards. Okay, and this tension will pass on to here as well. Okay, there all in this string also there will be tension T. Okay, and since it is the same string, so the tension will be equal. Okay, the string is same. Okay, so the tension will be equal. So this, if this tension is T, this tension is T, there will be a tension T dash here. This tension will not be same because this is not the same string. Okay, जो ये वाली string है जिससे pulley attached है, the string from which the pulley, this is the pulley, the string from which the pulley is attached to the ceiling, this is the ceiling, let's say ceiling. This string is different, and this string is lifting the weight of both M2 and M1 block, whereas this the string which is passing over the pulley, okay, some part of that string is lifting the block of lifting the weight of M1 block, and the other part of the string is lifting the weight of M2 block. But despite this, the tension will be same because within a single string, the value of tension is same. But since this string is different, this is T dash, the value of tension will be different, and it will be equal to 2T here. Okay, because this, understand this system like this. This is the pulley, this is the tension, this is attached here. Okay, and there are two masses. Okay, so if in this part the tension is T, if in this part the tension is C, so the total tension in this T dash part, the upper part will be equal to the sum of both the parts. So this is T, this is T, it will be 2T. Okay, and if this is 2T, this is 2T, it will be 4T. Okay, but the tension in both these parts remain same because this is a single string. This is a single string which is passing over this pulley. It's a single string. Okay, so the tension in both these parts will be same, and the total tension upwards. Okay, in this portion of the string, which is carrying the weight of the pulley, supposedly, will be sum of the tensions in both these parts. Okay, sum of the tension. If this is 2T, this is 2T, there will be total 4T. If this is T and this is T in this side, the total tension here will be 2T. So that's how you can remember this relation between the in the Atwood machine. Okay, so the total tension at the top is equal to the sum of the individual tension which is hanging over the pulley. And these tensions are due to the mass of these blocks. These tensions are present due to the mass of the block because the mass, this block is hanging downwards. This will produce some extension in this string. There will be some extension. Into this extension, the tension will come similarly there. This block is moving downwards, so this string is overall moving downwards. So the string will try to take this M2 block with itself because it is attached to this M2 block. So M2 block will move upwards. Since the M2 block is moving upwards, okay, and there is some weight which is acting downwards. So there will be an extension produced in this string also. This part of the same string that will also be T. Okay. So first of all, what you have to remember is that the tension in both the parts of a single string, okay, the tension in a single string remains same. There are no different values of tension in a single massless string. In an Atwood machine, the string is massless, okay, and inextensible. Massless and inextensible. You know the meaning of both these words. ठीक है, अब देखो होगा क्या. Supposedly, if I say you give me the acceleration of the block M1 or M2, first you should remember is what you should remember. Tension will remain same throughout the blocks, throughout the string. Tension will remain same throughout the string. And secondly, both the masses will move together. Both the masses will move together. That is as a system. Both the masses will move together as a system. Now, I am drawing the FBDs now. I'm drawing the FBDs. First of all, I'm drawing for the M1 block, this block. So on this M1 block, there is a mg force which is due to the weight of the block acting downwards, and there is a tension which is acting upwards. Okay, so due to the weight of the block, there will be a force which is acting downwards, m1g, and the tension will be acting upwards. Okay, and since I know that the net result is that the M1 block is moving downwards, the net acceleration is towards downwards. So I know that the M1G is greater than the tension. So what I can write is M1G minus T is equals to what? M1A. Bigger force minus smaller force is equals to the net net force. Okay, so net force is net mass into net acceleration, A net. Similarly, for M2, if I draw the FBD for M2 block, this is the M2 block. There is a force M2G acting downwards on this as well as a tension acting T upwards. Now I know that the M2 block is moving up in the upwards direction because they form a system, and the system should remain together. So I will write the bigger force. I know that tension is bigger force because it is moving. Net acceleration is towards the direction of tension. So tension is bigger than m2g. So bigger force minus smaller force, tension minus m2g will be equal to the net force, that is m2 into a. ठीक है ना भाई? बड़ी में से छोटी फोर्स को माइनस करेंगे क्योंकि नेट एक्सेलरेशन ऊपर की तरफ है, तो बड़ी फोर्स कौन सी हुई? टेंशन। तो टेंशन में से आप किसे माइनस करोगे? m2g को, और किसके बराबर लिखोगे? नेट फोर्स के। तो टेंशन माइनस m2g इज m2a. These are the two equations which you can make. Or if I draw for pulley, अगर मैं pulley के लिए लिखूं, so for pulley you can write that the T dash is the total tension which is equal to 2T directly. Okay. If I ask you what will be net acceleration in this case, what will be the net acceleration in this case? A net. You will write, so net acceleration will be the net force minus net force minus not minus, net force upon net mass. So what is the net force? What is the net force in this case? Net force will be m1g minus m2g. Do you understand why? Why I am saying net force will be m1g minus m2g? Why this is net force? Because see the diagram again. M1g is trying to pull the M1 block downwards. What is M2g doing? M2g is trying to pull this M2 block downwards. But what is the actual result? M2 block, is it going downwards? No. M2 block is going upwards. देखो जहां तो दोनों M1g M2g यही रहे हैं कि M1 को और M2 को नीचे नीचे खींचे, लेकिन M1 और M2 में से कौन सा नीचे खींच रहा है एक्चुअल में? इट इज M1. M1 block वो block है जो एक्चुअल में नीचे खींच रहा है. ओके, so M1 is the block which is actually moving downwards, and if M1 is moving downwards, M2 has to move upwards because it is a constraint, because they are connected by a same string. तो अगर M1 नीचे जाएगा तो M2 को ऊपर ही जाना पड़ेगा. So in reality M2 block is going upwards, but what is M2g trying to do? M2g is trying to pull this M2 block downwards, but that's not happening. So that means it is a net force, it is a weaker force. So I can say the net acceleration will be m1g minus m2g, that is net force, upon my net mass, that is m1 plus m2. Okay. So I can take the g common and I can say m1 minus m2 upon m1 plus m2. Okay. This is the formula to calculate the net acceleration if you are given a question like this. Okay, that the two masses are hanging from a pulley and they say calculate the net acceleration. So this is the formula: G m1 minus m2 upon m1 plus m2. Similarly, if they say calculate tension, the shortcut is 2 m1 m2 upon m1 plus m2 into G. 2 m1 m2 upon m1 plus m2 into G. Now how do you get this shortcut? सुनना है आपको? परेशान तो नहीं हो गए? I will explain you how do you arrive at this shortcut formula or the direct formula. But okay, stay with me. I'll tell you the way to do it. You have got the value of acceleration. Okay, the value of acceleration you've calculated. Put the value of acceleration in any one of the equation. You can put the value of acceleration in this equation, and from there you can calculate the tension, or you can put this value of acceleration in this equation. Here, and then also you can calculate the tension. Okay, so if you put this value in this equation 2, let's say this is equation 2 and this is equation 1. If you put the value in equation 2, what you will get? See, equation 2 is T minus m2g minus is equals to m2. T minus m2g is equals to m2a. Okay, I'll put the value of a. Okay, so T minus m2g is equals to m2 into g m1 minus m2 upon m1 plus m2. And if you solve this, you can finally arrive at the final formula. Okay, which is your 2m1 m2. I'm not solving this because this is a time pass thing. You can solve this at home. If you're not able to solve, you can ask me. Okay, but this is a very, very time pass thing, and you know where this is asked, so you can. What happened just now? Just a minute, beta. You should directly remember the formula. You should directly remember the formula. For ANET, you know derivation आपको आता है. For tension, you should directly remember the formula. If they ask you which is the tension in the string, this is the formula to calculate the tension in the string. 2m1 m2 upon m1 plus m2 into g. First there is multiplication between the m1 and m2 और नीचे वाले डिनोमिनेटर में एडिशन है. तो 2m1 m2 upon m1 plus m2 into g. ओके, इसको डायरेक्टली रिमेंबर कर लो, वरना आपको तरीका बता दिया. अगर आपको डिराइव करके देखना ही हो, आपको तरीका बता दिया. और एक क्वेश्चन करते हैं, उसके बाद we'll end the class for this. The ceiling. Okay, and the two masses hang from this. The first mass is 5 kg. The second mass is 10 kg. Okay, and the system is moving downwards. Okay, A net is towards downwards. So you have to calculate the acceleration of the system. Acceleration, net acceleration, and tension. Two things. Calculate the acceleration in the system and the tension in the string. This tension. ओके, आंसर आया इसका किसी का भी? ट्राई क्विकली ट्राई टू सॉल्व इट. आपकी जूलॉजी क्लास का भी टाइम हो रहा है. Okay. Bonus. I'll give you bonus. How will I give you bonus? I'll calculate this for you. क्या क्वेश्चन है? G into m1 minus m2. The formula is G into m1 minus m2 upon m1 plus m2. इतना टाइम क्यों लगता है तुम्हें को कैलकुलेट करने में? 10 इंटू क्या है? m1 minus m2. इसको m1 मान लो, इसको m2 मान लो. ये क्या हो गया? 5 अपॉन कितना हो गया? ये 15. ठीक है, तो कितना हो गया? 50. 5 upon 15, which is 1 by 3. 1 by 3 into G. Okay, so 10 by 3. G की वैल्यू अगर मैं 10 मान ली है तो 10 by 3. This is your acceleration, 10 by 3. Okay. यहां पर आपको G की वैल्यू 9.8 थे, तो 9.8 by 3. टेंशन कैसे कैलकुलेट होगी? सिमिलरली 2m1 m2 अपॉन m1 plus m2 into G. 2 into 10 into 5 upon 15 into G की वैल्यू let's say 10. So how much is this? This is 15 to 100 and again 10,000 upon 15. इसमें क्या सॉल्व नहीं हो रहा? This is not, हाँ 15 to 10 100. हाँ ठीक है. Okay. Yes sir. Okay sir. Clear sir. Okay. We'll meet tomorrow. We'll do a similar question of this kind. इस तरह का एक और क्वेश्चन करेंगे. Do the join class on time so that we are able to finish this chapter quickly. Don't join so late and try to solve the questions quickly. We'll meet tomorrow. Okay. And all the best for your zoology class. Okay. Bye bye.